Okay, and I think we are live. Whoops, let me mute that. Cool. Awesome. Hey everyone, welcome to this Chainlink Hackathon workshop. Today we're going to be talking about JavaScript development environments. More specifically, we're going to be giving an introduction to Hardhat, talking a little bit about Truffle, and we're going to do some coding along fun stuff as well. So hope you guys are ready. It's going to be a fun one today. I'm just going to share my screen now. So share. Okay, can everyone see that okay? Okay, awesome. Let's go. Cool. So yeah, my name's Harry. I'm a developer advocate for Chainlink Labs. And as I said, today we're going to be talking about JavaScript development environments, Hardhat and Truffle. So first of all, let's just go through what we're going to be doing today. So we're just going to give a brief, 1-minute overview of JavaScript development environments in the context of, blockchain development. We're going to talk a little bit about Truffle. We're going to talk a little bit about Hardhat. Then we're going to do a demo with Hardhat. And then we're going to introduce our Hardhat Starter Kit. And then we're going to do a demo of our Hardhat Starter Kit. So let's go. So development environments. Most of you probably already know this, but essentially just a set of software tools to help you in your development process, to help you to build the stuff that you need to build, right? Pretty simple. And yeah, designed to maximize productivity and efficiency. So let's start off by talking a little bit about Truffle. So Truffle is probably one of the most mature and oldest Web3 JavaScript-based development environments. That means that it's really popular. It's got a lot of support. It's got a lot of, if you have issues and you're looking for a solution to something, chances are someone's come across this issue before because Truffle's been around for a while. So it's a JavaScript-based development environment, and it's got integrations with Ganache for running local blockchains and Drizzle for front-end stuff. And yeah, it's really mature and lots of support available online. For our demos today, we're going to be focusing on Hardhat as opposed to Truffle, because Hardhat is a little bit faster with doing things such as tests and things like that, and Hardhat's not as mature. However, it is very popular at the moment. However, if you want to see some examples of Truffle in action in the context of Chainlink development, you can head to our GitHub repository and have a Truffle starter kit here. So I recommend you check that out. Have a look at the instructions for getting that going. Right, but for now, let's continue. So let's talk about Hardhat now. So Hardhat is formerly known as Buildler, is a JavaScript development environment as well for basically creating, deploying, and interacting with smart contracts on any EVM chain. It's got some cool features such as tasks, which are these kind of reusable set of scripts, basically, which we'll go through in a minute. It's got a local Hardhat network to simulate running a local blockchain on your computer to save you having to deal with gas and things like that when you do your development. It's really well maintained, and there's great support for it as well. If you have issues and you go to the Discord, you're always going to get help there. It's also got support for TypeScript, actually. So you can find Hardhat at hardhat.org here. And we're going to be doing some stuff in the documentation today as part of our demo. So moving forward, let's talk about tasks and plugins. So Hardhat has what are called tasks, and tasks can be thought of as kind of like a script, but kind of more modular and flexible, right? And they can be called from within other tasks or scripts, etc. So an example of a task is maybe funding your contract with Link, right? And anything you can do with a script, you can generally create a task for, and you can kind of interoperate between the two. I personally like using tasks more than scripts because I feel it provides slightly better UX. When you're executing a task, you just have to specify the task name. You don't have to specify the file extension or the path or anything like that. And I think it's got better integration into the magic of Hardhat as well under the hood. However, you can use tasks or scripts whenever you need to basically do stuff with your contracts. So a plugin is basically packaging a task into something that then can be imported into other projects, basically. So if you go to hardhat.org plugins, you can see there's a whole bunch of plugins that are officially supported. I'm not sure why the page isn't loading here, but anyway, yeah. So lots of plugins, and you can create tasks to basically do certain things that you find yourself doing often as part of your smart contract development, such as interacting with contracts, calling certain contract function names, etc. So Hardhat has also what's called the local Ethereum network, local Hardhat network, sorry, and this allows you to run and test your code without having to deal with a live public network such as the Coven testnet or mainnet, etc. So you can run this in standalone fashion on your computer, and you can connect it to external clients. You can do a whole bunch of stuff with it, basically. So you can kind of think of it as just like another network, like Coven or mainnet, basically. Another cool feature of Hardhat and the Hardhat network is that you can fork the mainnet, right? So basically what this means is when you create a local Hardhat network, it's generally a blank slate that has 0 blocks, 0 transactions, and every time you do stuff, it will get added to the chain. However, there are certain scenarios where you might not want a blank slate. You might want to have all of the mainnet contracts available for you to interact with and do stuff with. So you can do what's called forking the mainnet, which basically takes a snapshot of the mainnet at that point in time, and that becomes the starting point for your local Hardhat network. So when you deploy your contracts, those contracts can then even interact and do stuff with mainnet contracts on this local fork. So yeah, really cool functionality there. All right, let's get into a demo now. So in this demo, we're going to create a new Hardhat project from scratch. We're going to set the config in it. We're going to create a basic smart contract. We're going to create a script to deploy the smart contract. And we're going to create some tasks to interact with the smart contract. We're going to do that on a local Hardhat network and the Coven network as well. So let me just bring up my VS Code. Cool. So the first thing we need to do is we need to install Hardhat. So I'm going to go to the installation section of the docs here at hardhat.org. And here's the npm command. So for Hardhat, you need to install, have Node.js and npm installed. So if you haven't done that, you can head to nodejs.org and install the latest version. So I'm going to create my first Hardhat directory. And I'm going to install Hardhat here, and that might take a minute. While that's loading, we'll go to the configuration section here. So Hardhat has a config file called hardhat.config.js. This is the file that basically has all the global settings that Hardhat needs. It has all the networks that you're going to be deploying to. It has the Solidity versions that you want to compile contracts against, etc. So there's a good template one here in the config section. So I'm actually going to grab that one and copy it. Okay. It should be finished any second. Cool. So I'm just going to open my VS Code to that folder now that I created. Cool. So now that we've installed Hardhat into this folder, I'm going to run npx Hardhat. There we go. And what we're going to do is we're going to create an empty hardhat.config.js file here. And as you can see, we have a package.json, a node modules folder, and an empty hardhat.config.js here. So now I'm going to paste the contents of that template hardhat.config file that I had. And we're going to use this as a basis for setting our own config, right? So the first thing I'm going to do is I'm going to change the version of Solidity to 0.8. There we go. The next thing I'm going to do is I'm going to change ring.kb to Coven. And I'm going to change this URL to Coven RPC URL. I'll explain this in a minute. And accounts to private key. Cool. So we need to create a couple of environment variables to basically set the variable for our account that we're going to deploy and interact with contracts, right? So we need to basically store the private key or grab the private key from somewhere for that account, and also a connection to Ethereum Coven network. So we're going to be using Infura for that. So I'm going to create Coven RPC URL, and I'm going to grab that from an environment variable, Coven RPC URL, and private key. We've got private key. Cool. And the way in which we do this is we're going to use a library called .env, right? Which allows us to store those sensitive kind of things in a .env file. So I'm going to run npm install .env to basically install that library. And while that's running, I'm going to import it here. So you go require .env .config. Cool. So that basically will allow us to store these variables in a .env file, and then they should be obtained from that .env file, and we can then use them in our config file here. So .env .example. So the way you do it is you'd go private key equals, then you get your private key from your wallet, whether it's MetaMask or whatever, and put it in there, and RPC URL equals, and you grab your, you go to Infura or any other Ethereum provider if you're not running a node on the network that you're connecting to, and you grab the URL string for connecting to that network, and you kind of plug it in here, right? I've got a pre-filled one of this with my private key and an Infura key, so I'm going to just quickly copy it into my local folder. So that should be good to go. Cool. All right. So what is next? So we're gonna use a plugin to basically connect to Ethereum and do stuff. So we're going to use Ethers, Hardhat Ethers plugin. So if we go down to the docs and go to Hardhat Ethers in the plugin section, you can see here is a command to install that, basically. So I'm going to go back to my CLI here, and I'm going to install that. So while that's installing, we're going to then set some more details here. Cool. All right, that's done. So we've set our .env file. We've said that we want to use the Hardhat network, the Coven network, using this connection URL and this private key. And now we should be able to create our smart contracts. Sorry, there's one more thing. So once we've installed Hardhat Ethers, we're going to import it here in our Hardhat config file. There we go. Cool. So we've set our config. Let's create a smart contract. So we're going to create a new folder called contracts, and we're going to create a file called my first contract.sol. Okay, this is going to be a basic smart contract that just sets a value. So Solidity version 8, contract my first contract, uint number integer. We're going to set the number to 0 initially in our constructor, and then we'll have a set number function number public, and we'll say number equals num, and then we have a getter view returns uint, and we'll return number. A very simple contract. I think that is all we need here. Now, the next thing we need to do is we need to, oh, whoops, I accidentally pressed enter. The next thing we need to do is we need to compile this, right? So to basically compile it, we run a command, basically npx hardhat compile. And what that will do is it will take a look at the config here, and just quickly, I'm going to change the default network to Hardhat. Actually, shouldn't be Rinkeby, because that's no longer a network in our config here. So what that will do is it will go into our config file here, and it will find our version, our specified versions that we've specified here, and it's going to see that we've specified version 0.8.0 here. Which basically it will then take and it will compile our smart contracts with that version, right? So let's clear this and go to npx hardhat compile. Oh, just didn't like something. Let's see. Over Solidity 0.8.0. Oops. Let's try again. Okay. We have a compiler error here. There we go. Wasn't closed. Okay, let's try again. Okay, let's take a look at this. Okay. There we go. One too many of those. This is what happens when you code live on the fly quickly. Uint, not unit. This is how you know it's not pre-recorded and it's a live workshop. And public. All right, that should hopefully be it. Cool. Compilation finished successfully. So once it's compiled, you can actually go into the artifacts and cache, and you can kind of see all the metadata associated with the contract. So you can see the ABI, and you can see the bytecode and things like that. So Hardhat actually uses this when you kind of do deployments. So once that's done, we're going to now deploy our contract. So if we go to the deploying your contracts section, you can kind of see a basic script for deploying a contract using ethers.js. So we're going to use that as a template, and we're going to go back to our project, and we're going to create a new folder called scripts. And in there, we're going to create a deploy.js. So we're going to paste that in. So the only thing we need to do here is, so this is just a simple ethers.js script for getting a contract that we've compiled and then deploying it to a network. And all we're going to do is we're going to change greeter here to my first contract, which is the name of our contract. And we're going to set this to my first contract with a little m. And that should be it, I think. The contract doesn't have any parameters in the constructor. So we're saying from that metadata that we created, basically get my first contract and deploy it to the specified network in hardhat.config, which at the moment is set to Hardhat. So I'm going to open up a new terminal window. And I'm going to start the local Hardhat network. So npx hardhat node is the command for that. As you can see, it generates a whole bunch of accounts of private keys. So that's done. So now that we have that running, we should be able to deploy our contract to the Hardhat network. So let's go npx hardhat run, and then scripts deploy.js. Cool, contract deployed to, and we get an address here. So we've created a script to deploy the contract to the local Hardhat network. Let's create some tasks to interact with the contract. So create a new folder called tasks, and I'm going to create a new file. I'll call it my contract tasks.js. Cool. So what we'll do now is we'll go back to the docs and we'll go to creating a task. And if you scroll down, you should see an example of creating a task, basically. So I think, yeah, we'll take this one. So I'm going to literally paste this example in our tasks file. We're going to remove Web3. We don't need that. So we need to create two tasks, one to write, to set the number in our contract, and one to read the number. So the first one we'll do is read number and give it a description. Reads the number. So what parameters does this task need to take? It needs to take a contract address. So that is the address of the deployed contract that we want to interact with. And I think that's it. And then in the set action, all we need to do is basically put the logic that we want in the task in here, right? So basically what we want to do is we want to grab we don't need these anymore, I don't think. I'm going to go const contract address equals task args.contract. So from these task arguments passed in here, we're going to get contract and store it into something. And we'll go const my first contract equals await ethers.get contract factory my first contract. So just like we did in the script here, we're going to get the my first contract deployment here. And in addition to that, we need to get the signing information. So this is specific to ethers.js. So we need to get the account details for the account that we're going to be signing transactions with. So we're going to go const accounts equals await ethers.get signers. Const signer equals accounts 0. We're going to get the first account. And const my first contract equals await new ethers.contract. And we're going to specify the contract address that we got here. And it's a my first contract. And we're going to use our signer that we got above to sign transactions. Then we say let result equals await my first contract dot get number. So this is the Solidity function that we're going to be calling, right? But I think we want to return it as a number. So what I might do is I might go integer and to string it. Result equals begin await my first contract dot get number dot toString. So that's basically getting our signing information for our account, creating an instance of this contract at this address specified, and then it's calling the get number function on that. And what we'll do at the end is we'll just say stored value is and result. Cool. So that is the read number task. What I'm going to do now is I'm going to copy that exactly as is and create another one called write to number. Writes the number. So this takes a contract parameter. However, we also need to specify a value to set in the number. So I'm going to add another parameter called value. And in terms of the set action, it's going to be very similar. We're going to also grab the value that was set. So we're going to say const value. Then we're going to get a connection to my first contract again, get signing information, and create a connection to it. That's all fine. And over here, instead of get number, we're going to say set number. Whoops. And we're going to value. Okay. We're going to pass in the value. We don't need to do any big integer stuff here. So let result equals await my first contract dot set number value. And we can say value set, and we'll put value in here. Okay, let's take a quick look. That looks okay to me. Whoops, task args. There we go. So we get a connection to the deployed contract. We get our signing information, and we call set number. Cool. So the next step, now that we've created our tasks, is we need to add these tasks to our local Hardhat runtime. So to do that, we basically just import the file here. So we can go require, and I believe the syntax is ./tasks/ my contract tasks.js. So that should import those two tasks so we can have them made available in our Hardhat runtime. Cool. So now let's test that out. So I'm going to deploy our smart contract again. Whoops. I've done something wrong here. Okay. We don't need that in our task file. Let's try again. Oh, sorry. All right, to deploy our smart contract, we're going to run our deploy script. There we go. So it's deployed to this address here. So now I'm going to run. As you can see, if I run npx hardhat, you can now see the read number and write number tasks show up. So I'm going to say write number, and we're going to specify the contract that we just deployed, and we're going to specify a value of 77. Cool. There we go. So value was set to 77. So that executed our write number task here, and it actually called the set number function in our smart contract. Cool. So let's change things up a bit now, and let's change our config to now run on Kovan. So let's deploy our smart contract to Kovan. So in this case, it's going to use our private key specified in the .env file and the Kovan RPC URL. So this one might take a little bit longer. We'll just check how we're doing for time. Cool. Contract is deployed to here. So what I'll do now is I will do the same write number task that I did before. I'll set that to 77. Cool, that's done. So now let's check the value with the read number task. So I remove the value parameter and I change this to read number. There's an error somewhere. Task args. There we go. There we go. Stored value is 77. Cool. We're running a bit behind time, so I'm going to leave it at that. So basically in this demo, what we did is we created a new Hardhat project. We set the config. We created a new smart contract. We created a script to deploy the smart contract. We created some tasks to interact with the smart contract once it's deployed. And we played around with this contract and deployed it and interacted with it on a local Hardhat network, as well as on the Kovan network. So let's move on now. If we have some time at the end, I'll answer a couple questions. Cool. So now that you guys have had a bit of an introduction to Hardhat, let's talk about the Hardhat Starter Kit. So the Hardhat Starter Kit is located in the Chainlink GitHub repository here. So if you go to Chainlink's GitHub at Smart Contract Kit, you can see it pinned to the top here. I'll just zoom in a bit. Hardhat Starter Kit. So basically, this is a pre-packaged Hardhat repository that contains all of the tools, config, and some boilerplate smart contracts for using Chainlink services and solutions, right? So all of the standard smart contracts for doing a simple API call, for interacting with the price feed, for creating a keepers compatible contract, for creating a VRF contract that uses VRF, etc. It's all packaged into this repository, and you can use that as a basis or as a starting point for creating your smart contracts, or just as a reference point if you want something to reference while you create your hackathon project. So it's got everything you need to basically get going with when you want to use Chainlink, and you can kind of even if you just want to reference it as a reference point for how to get a random number and how to create a task to interact with a contract that gets a random number, etc. It's great for doing things like that as well. So let's go through a demo for the Hardhat Starter Kit now. So I'm going to close all of this, and we're going to go to the Hardhat Starter Kit repository here. I'm going to go git clone. Right, so you just pull the code locally. You could do it with Git if you've got Git installed, or you could just grab it directly from here as well. It's up to you. I'm going to now change my folder. GitHub. Cool. So as you can see on the left, we've got a whole bunch of stuff here. So we've got a contract folder. So this contains all of the standard boilerplate contracts for Chainlink services and solutions, right? So the price feed consumer, the random number consumer contract for getting a random number, keepers compatible contract that increments a counter, and an API, simple API call example. So these are all the contracts that are found in our docs as well. So if you've interacted with these on Remix before, you'll be familiar with them. But these are the contracts in the starter kit as well. We've also got some mock contracts, which basically mock up things such as a link token or an Oracle contract when you're running on a local network, because when you're running on a local network, you can't interact with the actual Chainlink live network because it doesn't know about your local network. In addition to this, we've got a bunch of deploy scripts set in a deploy folder, right? And just like we went through creating scripts before to deploy contracts, it's very much the same thing. It's going through, it's grabbing compiled contracts, and it's deploying them to the specified network of choice, right? In addition to this, we have a whole bunch of tasks, right? So we've got some generic tasks such as, what's the balance of our account? What's the current block number? Withdraw link. But then we have tasks specific to contracts. So the price consumer contract has a read price feed task. The random number consumer contract has a read random number and a request random number task, right? And these are all very similar to the tasks that we created before. And you can kind of go through and see all of the logic in here. In addition to this, we've got some tests, but that's for another workshop later this week, so I'm not going to go through those. And finally, we have our hardhat.config file where we're importing a bunch of libraries, a bunch of tasks that we've created. We're setting a bunch of environment variables that are used, and we have a default network and some other networks as well, right? So the first thing we actually need to do, which I'm going to do now because it might take a while, is I'm going to install all of the dependencies by running yarn. And what we'll do after that is we'll set the .env file. So if you look at the folder contents, I'm just going to shut some of these. There we go. If you look at the folder contents, you'll see there's an example.env file, right? So sets a Kovan RPC URL. We're using Infura here, and we have a private key that needs to be set as well. So once again, you need to export this private key from your account or that you want to use for deploying and interacting with contracts. So if you're using MetaMask, you can extract it from MetaMask or whatever wallet. You can just extract it. And the Kovan RPC URL, sorry, you can use services such as Infura or Fuse, etc., to kind of get one if you need. So it's still installing. Once that finishes, what we'll do is we will start off with the Hardhat Network. So what I'll do is I'll start another terminal session here. And I'll start the local Hardhat network. So node. I can't do it yet because I haven't set the details. Okay, let's wait for this to finish. Let's see any questions here while we're waiting. How do you run tests, Mocha, in Hardhat? We have a workshop on tests in a couple of days. So we're going to be going through a whole bunch of stuff on the subject of testing then. So recommend checking that workshop out there. Let's see. Okay, we're done. So what I'm going to do now is I've got a pre-filled out .env file with my private key and my Infura thing. So I'm going to grab that and copy it here. So now that that's done, let's go back to our other terminal and let's try start our node again. So npx hardhat node. We'll give that a minute. So that actually compiles our contracts as well, if they're not compiled, which they weren't. And as you can see, it will start the node and we can see a whole bunch of output. Cool. So we have a node that's running. What we'll do now is our contracts are compiled and you can kind of see all the metadata that's created as well. So now I'm going to do npx hardhat deploy. So this is actually a plugin, the Hardhat deploy plugin. So you don't have to specify a script or anything. What it will do is it will go to a deploy folder here and it will run each of these deploy scripts in order, right? So deploy mocks, price consumer, API consumer, etc. And then up until this last setup contracts script here. So I'm going to execute that. And as we can see, we get a whole bunch of outputs. So the cool thing about the deploy scripts with the Hardhat Starter Kit is it gives you tasks that you can copy and paste to then interact with the contracts. So for example, for the price consumer contract that uses price feeds, it says we deployed your contract to this address. Here's how you can then interact with it by running npx hardhat, read price feed task, passing in the contract and a network. So I'm going to copy that and I'm going to literally paste it below. And as you can see, we have a return price here. So because we're running on a local network, it's just a static value that's not really from an actual price feed. However, what we might do now to make it a bit more real is we'll change the default network to Kovan, and let's deploy everything to Kovan now. So we'll just give it a minute to deploy. So as you can see, we get the output as well for every contract that's deployed, along with some task information that we can use to basically interact with the deployed contracts. One thing to note as well is the Hardhat Starter Kit has what's called a fund link task. So what this does is in this setup contracts deploy script here, for the API consumer and the VRF consumer contract, it'll actually attempt to pre-fund those contracts with some link before you when they're deployed, so that when you deploy them, they're already ready to be interacted with. You don't need to manually fund them with some link like you would if you were deploying those contracts with the remix examples, for example. So just to kind of save some time, basically. Cool, so that's done. So now let's go back to the price consumer output, and let's run the read price feed task with our deployed contract address. There we go. So that is the price there. I think that's the ETHUSD price. I think it's set to. So 4,195.48. So let's try another one. Let's do VRF because that one uses link. So let's call the request random number task, starting our contract. So that will call our task in our tasks, random number consumer, request random number. So that will go through and it will call the get random number function in our smart contract. So that will basically send a request to the VRF node on Kovan. And once that request is processed and sent back, you can see that we're given another command that we can run, npx hardhat read random number with our specified contract address to then read the result. that will probably take a few seconds to complete. Just checking how we're doing for time. So what I'll do is I'll copy the read random number command that was given, and I'll now execute it. And we wait. Cool. So we have a random number in our smart contract here. So as you can see, tasks are really great for creating small bits of code to interact with your contracts and do things with your contracts once they're deployed. And they're really easy to create. You can kind of base them off other examples and things like that. And you can use things like ethers.js or web3.js in conjunction with Hardhat, with the plugins that they created for them to interact with your smart contracts using tasks. So we're running a little bit late for time, so I'm just going to wrap things up here and see if there's any questions. So there's just a basic example of our starter kit. It gives you all the smart contracts, tasks, config, and things to deploy simple smart contracts that use Chainlink that you can then use as either a starting point or a reference when doing your smart contract development. So if you need to get help as part of your hackathons projects, if you're using Hardhat, Truffle, whatever, the best place to go is definitely in our Discord, chain.link /Discord. We have some hackathon specific channels, and we're constantly monitoring those, and we'd love to help you out there. If you have a Hardhat specific issue or question, Hardhat has got a great Discord as well. So if you go to hardhat.org/Discord, you'll get added to their Discord. They're always answering questions and helping people out. So I've personally gotten help from them multiple times in their Discord. So I can definitely recommend heading there if you have any Hardhat specific issues as well. Once again, our starter kits are pinned to the top of our repository here. So if you go to our GitHub smart contract kit, we have our Hardhat starter kit, our Truffle one, our Brownie one, which I think Patrick has gone through as well. So you can find those there for just getting started with using Chainlink in your smart contracts. And yeah, you can head to the docs for obviously for more info, as well as other hackathon resources and things like that. And yeah, just if you have any questions, feel free to reach out, and we'd love to help you out. So I hope this has been helpful for some people. I've got a feedback form that I'm going to paste into the comments here. Once I work out how to add a comment. And then I'll see if there's a couple questions, because we've got just a couple minutes. All right, I'm pasting the link into the YouTube chat. Cool, there we go. So yeah, if you guys want to give any feedback, yeah, feel free. We'd love to have it. So I'm just going to stop sharing my screen. Cool, let's see if there's any other questions here. So what do you think of using Hardhat in a remote server and deploy our dApps with DevOps tools so the Hardhat can be leveraged as a test server instance? Does this sound cumbersome? Any better strategy? I mean, it sounds feasible. I've never done it personally. However, if it gets you the results you need, I say, yeah, why not? I can't see why you shouldn't be able to do that. Any other questions here? Let's take a look. I'm going to scroll up because I know I may have missed some before. To install Hardhat again for every project, or is it a global install? I think you can do it as a global install. I don't think I did for this demo here, but it's just like any other npm package. Fork mainnet for testing is sweet. Yes, definitely is. If I had a little bit more time, I would have forked the mainnet today, but maybe on the Wednesday workshop in testing, we'll try and do some forking of mainnet. Definitely helpful. Let's see, any questions in the YouTube channel? Is Hardhat more popular than Truffle? If I only learn one, should it be Hardhat? That's a tough one, because Truffle is so mature now that there's so much stuff that's been created with it. However, Hardhat is probably more popular for new projects right now. So for example, a lot of the big DeFi protocols use Hardhat, so Uniswap, Aave, etc. If you go to their repositories, you'll see Hardhat in there. You'll see Hardhat configs, tasks, etc. So I'd say Hardhat is probably more popular now. However, Truffle is more mature. So it's personal preference, I guess, in the end. My recommendation is try both, see which one you like better, which one you find easier to work with. I personally like Hardhat. I feel it's a little bit quicker and easier to work with. However, it's personal choice. How to use with flash loans and keepers. That's a topic for another talk. I think we may have had a keepers demo yesterday, actually, so recommend checking that out. And if you want some information specifically on flash loans, if you head to our blog at blog.chain.link and search for flash loans there, you'll see there's some really good articles that talk about them. So hopefully that can help you out. Okay, anything else? Cool. All right. I can't see anything else here. So I think we'll wrap it out. We'll wrap it up now. So yeah, just want to say thanks everyone for watching. Really look forward to seeing what kind of stuff you build as part of this hackathon. Definitely reach out to us if you need help. Reach out to the Hardhat guys if you're using Hardhat and you have issues with Hardhat specifically as well. If you have issues with our starter kits, reach out to us. We would love to kind of help you out. If you find issues with our starter kits, please raise an issue in GitHub so we can kind of action them as soon as possible as well. So yeah, I'm going to sign off now and say thanks everyone for tuning in, and we'll see you next time. Bye everyone.